what is it that takes us further into the future? It exists in every visible detail. And somewhere in the unexplored possibilities, we imagine countless times that dry deserts become lush oases. And now it has become a reality. Sunlight spur a new ray of hope. Make the earth green and breathe new life everywhere. The size from rural to urban areas get simplified gradually. Conserve the nature and ensure seamless connectivity. Turning complexity into simplicity. Modular construction of data centers is designed for an intelligent digital world. To unleash cloud computing potential and to accelerate the smart future. Speed up for future transport. For every pleasure travel, green power is used to achieve an excellent experience. Modular power can be highly integrated and applied everywhere. To light up the moments you are looking forward to. Bring unlimited possibilities and make life better and convenient. Huawei Digital Power. Preserve Earth with technologies. For zero carbon, smart society. What is it that takes us further into the future? It exists in every visible detail. And somewhere in the unexplored possibilities, we imagine countless times that dry deserts become lush oases. And now it has become a reality. Sunlight spur a new ray of hope. Make the earth green and breathe new life everywhere. The size from rural to urban areas get simplified gradually. Conserve the nature and ensure seamless connectivity. Turning complexity into simplicity. Modular construction of data centers is designed for an intelligent digital world. To unleash cloud computing potential and to accelerate the smart future. Speed up for future transport. For every pleasure travel, green power is used to achieve an excellent experience. Modular power can be highly integrated and applied everywhere. To light up the moments you are looking forward to. Bring unlimited possibilities and make life better and convenient. Huawei Digital Power. Preserve Earth with technologies. For zero carbon, smart society. What is it that takes us further into the future? It exists in every visible detail, and somewhere in the unexplored possibilities. We imagine countless times that dry deserts become lush oases, and now it has become a reality. Sunlight spurred a new ray of hope, made the earth green, and breathed new life everywhere. The size from rural to urban areas get simplified gradually, conserve the nature, and ensure seamless connectivity. Turning complexity into simplicity. Modular construction of data centers is designed for an intelligent digital world. To unleash cloud computing potential and to accelerate the smart future. Speed up for future transport. For every pleasure travel, green power is used to achieve an excellent experience. Modular power can be highly integrated and applied everywhere. To light up the moments you are looking forward to. Bring unlimited possibilities and make life better and convenient. Huawei Digital Power. Preserve Earth with technologies. For zero carbon, smart society.
Hello, ladies and gentlemen. Welcome to Huawei SNEC 2021 Global Virtual Summit, Middle East and Africa. I'm Liu Xuan, Marketing Manager for Smart PV and Huawei. Digital power is the foundation of the digital world. Energy generation and deployment require strategic planning. And solar and renewable energy becomes the main energy source. Huawei and the key industry player is working closely with our global customers and help them to achieve energy and digital transformation. This year, for our friends and partners who are not be able to come to Shanghai during SNEC 2021, we will be bringing you to the SNEC exhibition and showing you highlights of our latest solutions and an exciting new product launch, and also our solution introduction. We believe Huawei innovative digital power will not only create commercial values, but will also contribute to the sustainable development for all. We hope you would enjoy this virtual summit and get to know more about how we lead in power digitalization for a zero-carbon smart society. Now, let's move to Huawei Night in SNEC Shanghai.
Distinguished leaders, distinguished guests, ladies and gentlemen, good evening. Thank you for taking your time and welcome to the Huawei Smart PV Night jointly hosted by Huawei and SNEC. I am Xingwen, your MC tonight. The annual SNEC is a time for old and new friends to meet. Today we're honored to be here with industry leaders, entrepreneurs, and ecosystem partners in the PV industry. First of all, on behalf of the organizers, I'd like to extend my heartfelt thanks and a warm welcome to all the guests and leaders who attend the event. Next, Let's give it a round of applause to Mr. Hou Jinglong, President of Huawei Digital Power Technology Company Limited. Distinguished guests, ladies and gentlemen, good evening. First of all, on behalf of Huawei Digital Power Technology Company Limited, I'd like to extend a warm welcome to all of you for attending this dinner. And I want to extend my heartfelt thanks to all customers, partners, and media representatives who have always cared for and supported Huawei Digital Power. Today we have had a very fruitful discussion, and we are grateful for your coming. At present, carbon neutrality has become the consensus and mission of the world. For China, the carbon neutral 3060 target will be the biggest and most certain event in the next 40 years. This is bound to be a broad and profound economic and social transformation, which would not only mean a revolution in energy production and consumption, but also an opportunity for all-round upgrading in all walks of life. It will affect all aspects of people's production and life. It is a challenge, and it also presents huge industrial and commercial opportunity. Looking at the global energy mix and system, it is an inevitable trend to build a new power system based on new energy sources. Photovoltaic is playing an increasingly important role in the high-quality development of renewable energy, and the photovoltaic industry has embraced historic opportunities. We believe that smart PV will become the main power generation system, and PV will become an inclusive energy source. The cost of PV power will continue to decrease, and renewable energy will become increasingly competitive, helping smart PV become the main energy source. Huawei's digital power, just recently established, is committed to powering 800 million people without electricity worldwide, and enabling more than 7 billion people around the world to use clean, efficient, and stable energy. Energy storage has become a necessary enabling technology to drive new energy from adaptive grids to enhancing grids. In a new power system, energy storage is distributed in scenarios such as source, grid, and load, and acts as a water reservoir and a grid regulator and a stabilizer. In our view, batteries are not equivalent to energy storage systems. The energy storage system is an integrated system that integrates electrochemical, power electronics, digital, heat dissipation, and AI technologies. The controllability of power electronics and the digital technologies resolves battery inconsistencies and uncertainties, ensuring the efficiency and the safety of the energy storage system. This is the mission for this industry. We want to be driven by both technologies and the market to facilitate industrial development. Low carbon and zero carbon will run through every aspect of production and life. All scenario zero carbon solutions such as zero carbon power generation, zero carbon mobility, zero carbon ICT infrastructure, and zero-carbon buildings are used to achieve green power generation, efficient power consumption, reduce energy consumption costs, and build zero-carbon campuses to achieve zero-carbon cities. In the carbon-neutral era, Huawei Digital Power will integrate digital and power electronics technologies, focus on clean power generation, transportation electrification, green ICT infrastructure, and energy storage, and work with industry partners to drive the energy revolution and build a green and a bright future. To address this issue, we will launch an all-scenario smart PV solution to facilitate zero-carbon power generation and bridge the power gap. Today, it is a great pleasure to gather with you at the SNEC and to witness and experience the development and the growth of the PV industry with all of you here. Looking forward to the future, I want to thank all the partners here for your perseverance that have really made it possible for the PV industry to grow. I hope to embrace change with all of you, seize the opportunities given by the times, and jointly contribute to the goal of achieving carbon neutrality at an early date. Finally, I hope everyone enjoys a nice and wonderful evening. Thank you. Thank you, Mr. Hou Jinlong, for his wonderful speech. Please be seated. I want to thank you for describing the new development opportunities and changes of the PV industry. How to seize new opportunities and embrace new changes? What innovations and explorations does Huawei have? Next, Mr. Chen Guoguang, Chief Operating Officer of Huawei Digital Power Technology Company Limited and President of Smart PV Business, will give you the answer. Let's give him a warm round of applause. Distinguished guests, ladies and gentlemen, let me again extend our heartfelt welcome to you for attending this dinner. SNEC every year is an opportunity for new and old friends to meet, and also an opportunity for industries to exchange thoughts. The industry launched its latest products and solutions. Huawei leverages this opportunity to release our latest R&D results to the industry. In the past decade, smart string inverter has been the cornerstone of our innovation, and we have been pushing the digital and intelligent transformation. Facing the future, building a new power system is our goal. We will release the all-scenario smart PV and storage solution, which will again lead the PV industry in the future and make PV the main source of energy in the new power system. First of all, I want to thank customers and partners around the world for your trust and support. In 2020, under COVID-19 and complicated external challenges, we realized over 42 gigawatt shipments in 2020 and maintained world number one for 6 years in a row. By May this year, we have 175 gigawatt of total global shipments, and every year we produce 224 billion kilowatt hour of clean energy, which is Beijing plus Shanghai total electricity consumption. Our teams remain in the field together with customers and partners, ensure project delivery, to ensure supply, cooperation, and service continuity. More importantly, around the world, there are 800 million people who don't have access to electricity. As PV costs dropped continuously, we can use PV to provide them with electricity. In Cameroon, for example, our PV and the storage solution have provided electricity for 300,000 people and 35 villages around the world. 2.2 million people have been powered now thanks to the PV products. As the energy develops rapidly in China and other countries, the new energy installed capacity has achieved more than 50%. In Mexico and Australia, the local grid requires PV plants to provide the same features that traditional power systems have, and China's HVDC requires stable operation of a new energy in SER 1.5. Before, PV and storage stations were built in remote areas, and accidents only impact the system itself. But today, PV and power storage are more and more in the campuses, buildings, homes, and be part of people's production and life. And physical and property safety are vital. In Australia, United States, and in Europe, the DV arcing of a PV and a faster shutdown has been made a mandatory requirement. All of the rooftop PV and storage must have these capabilities. In future, for PV to become the main source of energy, the grid connection and the safety are the mandatory requirements that must be met. In order to achieve carbon neutrality, the key is to build a new power system based on new energy. About the new power system, there are 4 features. First, high proportion of renewable energy. In power generation, PV, wind, and storage will replace traditional energy and become the main source of energy. For the utilization, the source, network, load, and the storage will be part of the home and campuses. From traditional power consumption to a consumer to producer transmission. Number 3, high intelligence, high degree of digitalization. In the future, the grid will also become digitalized. Generation, distribution, transmission, and utilization will all be based on power electronics.
The next feature is high degree of digitization. In the future, a large number of PV stations, storage systems, distributed storage systems, and electric cars need to be coordinated in a unified manner. We need to rely on digital technology so that all the systems can be controlled. Going forward, the stability of new electric power systems will be the digital technologies. In digital and electrification technologies, Huawei has extensive experience. We have 5 core technologies, from underlying technologies to applications. We target sensing, connectivity, cloud, data, and algorithm. We have presented 4 large-scale application scenarios. We will also build one cloud for streamless power generation, storage, and consumption, and help to build a new power system and helping to achieve carbon neutrality. Now, let me show you a small video about the all-scenario smart PV and storage solution. In this video, it shows our solution from 1.0 to 8.0. I'm very thrilled. Over the years, we have stayed customer-centric and keep innovating. We have overcome one difficulty after another. We have brought industry with numerous innovations and created more value to our customers and partners. We have received recognition and rewards from them. The solution we're launching today is also supported by our partners. Now let me give you more details about this innovation. The first solution is FusionSolar 8.0 Smart PV Generator. The traditional PV generation is supplementary generation unit. Going forward, to become the primary source of energy, PV needs to reduce the unit cost. It also has to be fully comply with the most advanced technologies. To achieve that, we have achieved the 1,500 volt bipolar smart string. This will help us to achieve the synergy of PV and storage, achieve the greatest efficiency and the quick scheduling and unified management. So this architecture can help PV stations reduce LCOE. The Smart String ESS is just like the string inverter we launched 10 years ago. It can greatly increase efficiency. We also put forward grid forming. This is the key algorithm in Smart PV solution. It can turn the PV into a voltage source. Using the string solution and grid forming, we can achieve adjustable frequency and storage solution so that PV stations can really become the smart PV generator. Why can the architecture reduce LCOE? With an increase of voltage, more energy can be transmitted. We use 1,500 volts to achieve higher voltage and give us more sub-array. Using the 3,000 volt, we can achieve 3 times efficiency. We can save 10 cents per watt. Our solution features optimal investment, higher yields, smart O&M, and safety and reliability. And I want to emphasize that using our architecture, it is symmetric design. It is fully in line in the low voltage requirement. It applies to all the requirements of the industry. We can achieve industrialization and also more efficiency. This is more details about the Smart String ESS. When we just entered the PV sector, it used centralized inverter. One control unit manages about 200 strings. They cannot be actively managed. So by presenting the string ESS, one control unit manages 2 strings, increasing the precision by 100% and greatly increasing the accuracy. Today, we see that the storage industry is just like the PV sector 10 years ago. One control unit manages 2,000 chips. The inconsistency of chips affect the storage efficiency. we have greatly raised the management efficiency by 100 times. This is the key feature of the Smart String ESS, that is precise management. This solution features more energy, which increases discharging energy by 15%, and simple O&M, which saves 170 RMB yuan per megawatts year. It is also safe, highly safe and reliable, which achieves active alarms, system quadruple safety protection. Will be able to address the inconsistencies and uncertainties in lithium batteries. The efficiency of charging and discharging can be increased by 15%, and the expected storage cost of LCOS can be cut by 20%. Using this architecture in our day-to-day operations, it can reduce the SOC of batteries. We don't need to have manual checks at the stations. We can also have hybrid use of old and new batteries. This reduces the O&M costs by a large margin. Grid forming is a technology that enables PV voltage source attributes and aligns grid ties features with synchronous generators. We need to completely overhaul the control. We need to proactively control the frequency and voltage using the 1500 double string. And grid forming, we have achieved a good mechanism to control the voltage source. Recently, together with Shanghai Grid, we did a research, and our research shows that PV generating mode has increased the efficiency of renewable energy access. It has boosted the efficiency by 13%. Under the current grid, as long as you have installed this system, and you can have additional 1.3 gigawatts of renewable energy. This is a great boost to the use of renewable energies. This is the greatest value that can be brought by the smart PV generator. For PV to become a primary energy source, security is the foundation of everything. We believe there is room for improvement in safety. DC protection has clear weaknesses. When there are circuit breaks, DC will encounter challenges. In severe situations, there will be fires and other hazards. So this year, this has been a key focus of the industry. We have achieved 3+4 safety protection for smart PV and storage system. On the AC side, there is also hazards due to low voltage. There can be damages to the boxes and fires. We have released a new solution that increases the safety of low voltage. In middle voltage, we also support switch and disconnector fuse. We use AI means to identify circuit breaks, which greatly improves the safety of storage systems. We use modular PCS architecture to achieve 4-level safety protection and coordination. On top of great big grid power stations and generators, we have also launched the Green Residual Power 2.0. On top of the 1+3 architecture unveiled last year, we have introduced the 1+3+X architecture for smart energy use. We have secured all the steps in the entire process, implemented smart scheduling. On the power generation, we can have 28 kilowatts of power on rooftops. The power generation volume is 30% more, and we are also able to achieve higher energy volume. In another case, the traditional method is only half as good. To give you more details, this solution includes yield increase by up to 30%, battery charge and discharge capacity improved by 10%, self-consumption rate increased by 10%, and more safety. When it comes to safety, we are using AI smart protection and to achieve shutdown within 0.5 seconds to prevent fire. We have also achieved zero voltage in emergencies, providing more safety.
The storage system has been integrated with AI detection for proactive prevention, and we also have reactive security. Through this, we make sure that there is a system-level proactive security for home green power. And today, we launch a digital feature, which is AI-based PV storage synergy. We know that PV power production and utilization are not matched during daytime, and there's only 60% of power generated used, and the rest will be sold at a much lower price. However, AI-based PV storage synergy can solve that problem efficiently. Through AI algorithm, we bring in the weather pattern and the user utilization pattern for big data analytics, so that under different weather conditions, the PV power generation and the home power utilization situation can be coordinated, so as to achieve the optimal match under each scenario. Let me give you several modes. In the sunny mode, if we forecast that during noon there is a PV peak shaving, then AI will tell the storage to reserve some space to accommodate the surplus power. Under rainy day, our algorithm will tell the storage system to charge the night before during the valley price period. If we believe we have PV power to go to the grid, we can see which families can be prioritized, such as laundry machine, EVs, and others. These are units that can be configured flexibly by AI. It was 60% of self-consumption rate during PV only, and now 85% under Green Home Power 1.0, and will be 95% under Green Home Power 2.0 era. Apart from this solution, today we bring the Green Business Power 1.0 through Smart PV Optimizer and ESS storage. We can provide 4 scenarios. All the features are based on the common architecture. In Jiangsu, one factory, we had a 156 kilowatt rooftop PV plant. Intelligent component have solved the blocking by a water tower issue. The PV plant capacity was improved by 6.3%. We work with PetroChina in one plant in Wuhan. PetroChina is worried about security, but they know that we can achieve fast shutdown and arcing prevention on the rooftop. This solution was quickly adopted in the PetroChina sites. Around the world, there are a lot of areas without access to mains or only have a weak mains. We provide affordable off-grid PV replaces diesel generator solution. There are about 50 million diesel generators and an increment of 5 million DGs every year. The fuel cost is high, so is the maintenance cost. The noise, the pollution, and the reliability are all big problems. The core of the off-grid PV solution is the storage, mains, and the DG, smart scheduling technologies, as well as AC and DC reliable power supply, which can reduce the power generation cost by 60%, and it can replace the traditional DG to protect the environment. We can cover from kilowatt to megawatt, from city to remote areas in Cameroon, in Africa, in Sea Island in China, and among many other regions around the world. Lastly, we use Energy Cloud to fully connect all scenarios. For the PV side, through refined component management, we can monitor the condition of each module. For the storage, we will provide modeling of 3D for the storage. And also BMS on the cloud can also support this management. The smart IV curve diagnosis is the only one in the industry that reaches L4 for all the aspects, which can reduce more than 20% of O&M costs of power plants. The SDS features intelligent DC power generation system. It can automatically identify shades and unsunny weathers. In one project in Guangdong, for half a year, SDS power plants generates more than 1.6% of power than others. Through AI-based PV plus storage synergy, we keep reducing O&M cost and improve maintenance experience and realize the autonomous driving of a PV and a storage. In the carbon neutral time, we focus on digital and power electronics technologies and promote the energy revolution and build a green and a bright future together with industry partners. Thank you.
Thank you, Mr. Chen. Energy storage will be the key direction of new energy development in the future. How can Huawei Smart Street Storage solution meet the challenges? Next, I'd like to invite Dr. Gu Xin, General Manager of Huawei Smart PV Global Solution Sales, to introduce Huawei FusionSolar Smart String ESS solution.
Hello everyone, my name is Xiong Gu. It's my great honor to present the Huawei FusionSolar Smart String ESS solution today. We all know that the renewable energy is growing very fast and it will have a high penetration ratio of energy infrastructure in the future. But it brings risk to the grid since the technology are based on the current source which cannot be either stored or controlled. It requires participation of energy storage, which is based on voltage source technology, easy to store and to control. In recent years, energy storage is becoming more and more competitive in levelized cost of storage, revealing its brilliant future. There are several challenges in front of us, including safety issues, low efficiency, short lifetime, and routine but difficult O&M. We have visited a large number of storage plants around the world. What we have seen is not that perfect. In several plants, we found that the system efficiency was only about 80% almost after the first half year running. Several plants only had 50% capacity left after 3-year operation, while the design capacity at this time should be up to 85%. O&M is also a headache for the plant owner. Senior experts are required to inspect the entire plant once per half year. It is especially difficult in working on the calibration of batteries and the repair of batteries out of service. Many accidents of the energy storage projects like fire and explosion have occurred around the world in the recent years, mainly due to battery overcharge, over-discharge, or other faults. How to prevent such risks are of top priority of all plant developers. People may ask, why does energy storage system operate with an overestimated efficiency? According to 10-year experience in storage R&D, Huawei realized that the root cause responsible for this overestimation is the inconsistency in packs and racks. Under ideal conditions, all the packs and racks are the same. Nonetheless, the electrochemical storage has a factory tolerance, which is typically larger than that of semiconductor industry. When these packs or racks operate under temperature or current difference, such inconsistency of battery will aggravate. On one hand, operation currents are different due to different internal resistance. When all these racks are connected in parallel, they will be charged or discharged in different speeds. The one with higher current will charge or discharge faster. When it is fully charged or discharged, the system will terminate the charging or discharging, while the capability of other racks are undermined. On the other hand, temperature is important to storage because the storage process is essentially a chemical reaction which should be accelerated by higher reaction temperature. According to Huawei experience, when the temperature increased by 15 degrees Celsius, the lifetime of battery will be 50% shorter. Unfortunately, traditional storage solution only has a central air conditioner, which can lead to up to 20 degrees Celsius temperature difference inside the cabinet, and therefore a heavy degradation of battery lifetime. Today, it is my honor to disclose Huawei Smart String Energy Storage Solution, which is a combination of innovations towards resolving the above concerns. The concept of string energy storage is inspired by string inverters, which manage multi-MPPT circuits precisely to minimize the impact of mismatch between strings and improves the system energy yield. String inverters have advantage in terms of fall rate, system safety, and O&M efficiency, and have become a mainstream solution in the industry. Therefore, we propose the Smart String ESS solution. Huawei Smart String Energy Storage Solution includes the Smart String-based energy storage system, Luna 2000, Smart Energy Storage Controller, and Smart Energy Storage Management System. In one energy storage system with 2 megawatt-hour, 6 high-density racks are integrated in a 20-feet container, less than 30 tons, each with 21 packs. Batteries can be transported within the container, and on-site battery installation is not required. This prefabrication model also simplifies deployment. Only simple installations are required. Unlike other traditional batteries, Huawei system uses pack-level optimizer, rack-level optimizer, and distributed air conditioners to dramatically improve the system performance. Besides, our Luna 2000 system is a string-level control rather than the conventional central controller. With such innovations, 15% lower LCOS can be achieved with lower investment, more energy, easy O&M, safety, and reliability. Let's see more details here. First, the pack-level energy optimizer avoids capacity loss caused by mismatch. The optimizer improves available capacity, eliminates the package mismatch caused by the internal resistance difference within the rack and increase the discharge capacity throughout the life cycle. For central solutions, the performance of all racks are limited by the worst one, while for Huawei solutions, the packs will be bypassed when they are fully charged or discharged, and therefore all packs can be achieve their best performance. Let me show you this with a movie. This is equivalent to increase charge or discharge capacity by around 6%. Second, in a real world, the internal resistance of a rack is likely to be different due to reasons such as a manufacturing process or battery aging. A rack with a low internal resistance has a larger current and a higher charging speed. After the rack is fully charged, all other racks connected in parallel will stop charging, which causes capacity loss. The rack level management allows the racks to run independently, eliminating the mismatch between parallel racks, maximizing the potential of each rack, and increasing the discharging capacity throughout the life cycle by 7%. Let me show this with a movie too. Third, the distributed cooling architecture is used. Each rack is equipped with an independent string-level air conditioner to minimize the temperature difference between racks. Therefore, the temperature difference in the container is less than 3 degrees Celsius at 0.5 C. Let me show you this with a movie. Next is O&M. In traditional solutions, experts need to adjust the batteries on-site twice per year, resulting in high O&M cost. The smart string ESS solution does not require SOC adjustment. Manual adjustment is not even needed after pack replacement. New packs can be plug and play, and the charge and discharge are automatically optimized. Modular design is used for the entire system. As a result, a faulty pack can be isolated to avoid the impact on other packs in the rack. And manual SOC adjustment is not needed after pack replacement. The PCS, as a critical part in the ESS, also use a modular design. When one or multiple PCS fail, other PCS can ensure the normal operation of the system. The system availability can be up to 99.9%, offering great flexibility and scalability, minimizing the impact of faults and O&M cost. Short circuit inside the battery is a major cause of fire accidents. Intelligent internal short circuit detection can detect fire in a timely manner. Meanwhile, it can warn of fire risks. Currently, the internal short circuit detection can identify two types of short circuit. First is the instantaneous burst internal short circuit, such as a puncture by a foreign body. In most cases, the voltage drops very rapidly and causing thermal runaway of the electrochemical cell. The severe short circuit identification algorithm can quickly detect the fluctuation of the charging curve, actually identify and quickly alert on the internal short circuit. The second is derivative internal short circuit, such as those caused by diaphragm degradation, such short circuits are difficult to identify and can lead to severe internal short circuit if left unnoticed for a long period of time. The AI algorithm is used to accurately calculate the internal short circuit resistance, capture the slight deviation of the charging curve, accurately locate the potential risks, and warn for fire risk in advance. Huawei Smart String Energy Storage solution support DC coupling configuration. Unlike traditional AC coupling storage solution, DC coupling solution allows the sharing of inverter and transformer between PV and storage systems, which can not only reduce the overlapped investment on the PCS and transformers, but also reduce the efficiency loss from those overlapped equipment. Besides, DC coupling can save the DC power clipping loss by transferring such energy to storage and therefore further increase the yield. The traditional energy storage solution does not support the mixing of old and new batteries. Therefore, considering factors such as battery capacity degradation over time, excessive configuration is performed during initial deployment to meet the capacity threshold, peak shaving, and frequency regulation requirements. Traditional solutions require not only batteries but also PCS and even transformer station. This increases the cost and makes the future reconstruction very difficult. The Smart String ESS supports mixing of old and new batteries. Moreover, all the batteries are prefabricated in containers and are easy to deploy. Therefore, new batteries can be deployed with existing batteries when needed. This reduces the needed initial battery capacity by around 30%, minimizing the initial cost and eliminates the need for PCS to reduce the required investment. To summarize, the Smart String ESS solution adopts the innovative string, intelligent and modular design to implement refined energy management, increase discharge capacity, achieve optimal LCOS, and eventually achieves the transition from PV parity to PV and storage parity.
Thank you, Dr. Gu. High-power PV modules are also the main direction of PV development. How can Huawei's H3 solution match this trend? Now, let's welcome Mr. Rizwan Razik, CTO of Huawei Smart PV Middle East, to introduce how does Huawei latest H3 solution match the trend of high-power PV modules.
Hello, welcome. My name is Rizwan, and I'm the CTO for the Middle East region. Today I'll be talking about the FusionSolar Smart PV solution, and specifically, if we look at the upcoming slides, we'll be talking about the transition in the last 10 years to the next 30 years of transition of the energy demands. So here you'll see the specifics in the last 3 years where the energy mix has been below around 25% coming from renewable sources. And this mix will be drastically changing in the upcoming 20 to 30 years, where we will see development of large-scale wind, solar, and other renewable plants. Now, if we look at the specifications of grid codes globally from regions such as China, EU, we see that there is a development and aim for a carbon neutral transition in the next 30 years, which is delivering this by the development of the products available in the market. The development of the specific PV sector itself has drastically changed in the last 10 years. So if we start around 2010, where myself entered into the PV market in the UK, we saw small-scale PV plants becoming quite popular, and that was due to the amount of type of inverter technology and also the technology of the PV modules that were available. Now, if we look in the last 5 years, there has been a transition over to the 1500 volt technology. And this has been also developed with the PV modules available in the market, the transition of the structures becoming more widely used with trackers rather than the standard fixed tilt applications. And we also see the block size of the transformers becoming larger in capacity as well. Now, going forward from 2021, we see a transition going over to a system voltage of plus minus 1500 volt, which we call the bipolar 3000 volt applications. Larger block size capacities due to the inverter technology capacity sizes increasing, and also the technology of larger PV modules becoming widely available, which increases the current capacity coming into the PV modules themselves. With the development of the energy mix and the amount of renewable energy that is being penetrated into the grid, we can see here that there will be specific changes and creating a large amount of restrictions onto the grid operators on the amount of PV plants that are looking to be connected. So here on the left-hand side, you are able to see clearly that for Saudi Arabia, there is an available short circuit ratio well above 5. Now, with the estimated amount of plants looking to be connected, examples, the Sakaka PV plant that was connected back in 2019, and the forecasted plants that are looking to be connected, such as the Sudair PV plant, which is well above 1.5 gigawatts. These large-scale PV plants will start to create limitations on the grid applications themselves. So we can already see in regions such as in India, in Spain, and also in other regions such as China, the grid codes starting to be adapted in these types of applications. So examples of this are the short circuit ratio requirements becoming below 2, the total harmonic distortions requirements rather than the current applications below 3%. We start to see the applications requirements of being below 1%. So with the development of the PV wafers becoming larger in size, their edge-to-edge size are well above 215 millimeters. Now, with the PV modules becoming available in the market, we need to factor in certain changes, such as the 1500 volt technology, which is limiting specifications of the number of modules that can be connected in the string, the current capacity of the string itself, and this would then be impacting the limitations on the inverter technology. Now, we already seen quite drastic changes in the last 10 years where the module capacity has gone well above 600 watt plus. And this is something that we see as an inverter supplier increasing further by around 80%. So here is an example of the large-scale PV module suppliers that are globally very active, and we have worked very closely with them, whether they are P-type or N-type PV modules, that our specifications of technology of the inverters can very easily adapt. So very quickly we have adapted from the 400 to 455 watt modules with the M6 wafers, and going forward 500 watt to 660 watt plus, there needs to be a development of the PV inverters themselves. So we have adopted continuously our string inverter technology to accommodate for the changes that are happening with the wafer sizes. And this works hand in hand with the PV module suppliers themselves. Now, going into specifications of the details, why does the inverter technology need to accommodate with the PV inverters themselves? Now, as we understand, there is a PV module which is connected in series, which we call the string, and this PV module has a current output. Now, on certain technologies and inverters, this PV inverter will have a limitation on its maximum input current. Now, as we explained earlier, the PV module wafer size is increasing and the output current is increasing out of these PV modules themselves, which is creating a limitation on current clipping on the inverters themselves. So with our latest technology, with the 3 to 10 kTl M1 product, which we are releasing later this year, you will see a development of the input current increasing, allowing for the PV modules that are available in the market, the 550 watt plus, able to accommodate directly into these inverters and limiting that current clipping that would be occurring. Now also, in order to support the more small-scale applications, we're also accommodating a Sun 2000 600 watt optimizer, which will help further reduce the shading effect and increase the yield that the plants can achieve on the projects themselves. Now, for the C&I application basis, we can see that typically the 12 kilowatt inverters all the way up to the largest size that we currently have is the 100 kilowatt inverter. Now, very quickly, as we've seen the technology of the PV modules increasing, this then puts a limitation on the inverters. And as you can understand with the Huawei string inverter technology, we are typically having no more than 2 strings being connected into each MPPT for the C&I applications. So this puts a limitation on the current capacity on each PV MPPT itself. So where there is large, high current PV modules that are looking to be used and utilized with the Huawei technology inverters, we do suggest that 1 string to 1 MPPT solution can be accommodated in order for a most cost-effective yield and a favorable BOS for the application itself. So with the 1 string and 1 MPPT solution, we are allowing our customers to have a variation depending on the type of modules that they are looking to be connected. So with the 100 kTl inverter M1 product, we have 20 DC inputs and 10 MPPTs. Now, allowing for the 10 MPPTs, the customer is able to very easily accommodate low-powered PV modules that are having well below a 13 amp limit per string. We are able to accommodate 2 strings in parallel, which will allow for 26 amperes per MPPT. Now, with the high-powered PV modules, we are suggesting the application on the bottom left-hand side, where 1 string per MPPT to be connected, allowing for a very aggressive DC to AC ratio, whilst also reducing that clipping effect that would be happening. Now, for the large-scale, utility-scale applications, our latest solution, which is the Sun 2000 200 kTl H3, we are able to accommodate, once again, a different type of solution, but also accommodating the changes and adaptability of the PV modules that are available in the market itself. So with this product, we have 14 DC inputs and 3 independent MPPTs. Now, the key characteristic here is each MPPT is able to accommodate to a 100 ampere MPPT limit. So this allows for a mixture of strings to be connected into each MPPT, depending on the type of modules that you are looking to be connected, whilst also accommodating high-powered outputs, so the rated power of 200 watts, 200 kilowatts, and a 215 kVA maximum output power with this product. So with the maximum current of each MPPT being 100 amperes, we are able to accommodate a vast mixture of applications, whether we're looking at regions such as in Dubai or other Asia-Pacific regions, the module selection, such as the bifacial 500-watt modules, would be the most, let's say, favorable solution in the coming year of application. So the DC-AC ratio varies very drastically depending on the region. So whether you're 110% oversizing or whether you're looking at well above 130% oversizing ratios, we are able to accommodate that with this type of product, with also minimizing the DC power losses that would typically be happening on the clipping losses that I mentioned earlier on. So this inverter is able to accommodate up to 5 strings to each MPPT, and I'll go through the safety and the factor of that in the coming slides. So first of all, we need to understand clearly what are the limitations of increasing the number of strings per MPPT. So first of all is the hazards that would be happening. So we can analyze from our, let's say, recent applications from other vendors in the market, large number of strings being connected into a single centralized inverter. We can see applications where the risk of fire is quite common. Now, other inverters with single MPPTs, you would have multiple strings being connected, typically around 24, and this then creates a limitation and once again a burning effect with the increase of effect of high current being connected into a single inverter connection point. So with our latest 200 KTL H3 product, which would be typically connecting around 100 kilowatts of power into each MPPT, the effect of short circuit is increased. So we have integrated a smart DC tripping switch into each MPPT, allowing for the IEC 60947 standard to be compliant, whilst also limiting this to also be connected to the SCADA platform to ensure that when there is a fault happening on the PV plant, this can very easily be monitored and detected on your PV plant for a safe and smart DC string solution. Thank you very much for listening today. I hope you're all having a wonderful day and hope to see you in the Middle East very soon. Thank you and goodbye.
Thank you, Rizwan. Moving right along, I would like to invite our special guest for today, the president of Huawei Site Power Facility, Mr. Peng Jianhua, to introduce Huawei iPower Cube solution. Please welcome Mr. Peng.
Distinguished guests, executives, and partners, welcome. Today, we are releasing Huawei iPower Cube, a green off-grid diesel generator-free power supply solution. I'd like to start by expressing my gratitude to all of you for the contribution to this industry. Now, I will brief you on the latest solution from Huawei Site Power Facility. iPower Cube is a green power solution aimed at bridging energy divide and contributing to decarbonization. In rural areas of Asia-Pacific and Africa, power supply systems are outdated and power outages are common. Statistics shows that in 2020, power outage in New Delhi of India averaged 201 times per month, and each time lasted for around 1.78 hours, meaning 10 hours outage each day. In 2019, remote villages in Indonesia suffered 4 hours daily outage on average. Unstable power supply greatly affects a nation's economy, as is reflected in GDP growth. People often turn to inefficient diesel generators to get their work and life going. In Africa, 40% of electricity is generated by diesel generators, which gobble up 20% of their diesel fuel. 75% of businesses in Nigeria and South Africa have their own diesel Compared to wind, solar, and other power sources, diesel generators emit large volume of carbon dioxide. For each 1 kilogram diesel fuel burned, 4 kilogram carbon dioxide is emitted. Diesel fuel contributes to more than 10% of total carbon emissions in the world. Diesel generators also, according to climate change reports from UN, from 2015 to 2019, carbon emissions capped 2060. Meanwhile, PV and energy storage technologies are progressing, driving down cost of solar power and power storage. Statistics shows that by 2020, there are already 5,544 micropower supply projects. Global power supply and deployment ways are diverse. Eventually, our consumption of fossil fuel energy will drop from 40% in 2020 to 20% in 2050. It is against this background that we launch iPowerCube off-grid diesel generator removal solution. The aim is to bridge energy divide and make life and work easier. iPowerCube solution covers small, medium, and large-scale scenarios. By small-scale scenarios, we mean those with a power range of 0 to 10 kilowatt, such as apartments, country houses, and business stores, restaurants, and bank branches. iPowerCube S is for medium-scale scenarios with a power range of 10 to several hundred kilowatt, typically live scenarios such as small villages and small islands, production scenarios such as farms, and industry scenarios such as oil and gas wells, logistics parks, stations, and transportation stations. Large-scale scenarios are covered by iPowerCube P. The power of those scenarios is at megawatt level. Scenarios include large villages, large campuses, large islands, coal mines, factories, and industrial parks. Our off-grid integrated power supply solution for small, medium, and large-scale scenarios can well support areas with no or unstable power supply. iPowerCube solution generates electricity for self-consumption. There is no need to feed electricity back to the grid, so it does not affect power distribution system, and there is no need to modify the power grid for on-grid purpose. That's why the deployment cycle is shorter and cost is lower. Let me explain in detail what you can get out of iPowerCube. Let's start with iPowerCube P for large-scale scenarios. Normally, people use diesel generators or traditional PV systems to supply power in those scenarios. PV systems need AC coupling, which generates high cost and low efficiency, as it needs three-level conversions, more than one set of PCS and transformers, and storage systems whose service life is short. iPowerCube PE adopts DC coupling. Only two-level conversions are needed, so efficiency is up by 1.5%, and LCOE is down by over 20%. PCS and transformers are no longer needed, significantly reducing capex. For power storage, we optimize by battery pack and manage by battery string, making storage systems safer and its lifespan longer. Lifespan of the storage system can be extended up to 15 years. Levelized cost of storage can be dropped by over 30%. In such off-grid scenarios, diesel generators can serve as emergency backup. Our solution can schedule off-grid new energy and diesel generators accordingly to bring greater reliability. That is up to 99.99%. iPowerCube P off-grid solution for large-scale scenarios has already been successfully applied worldwide. In Cameroon, Africa, it powers villages to support people's life and work, accelerating access to electricity for people in Cameroon. Compared to traditional diesel generator solution, our solution lowers LCOE by 80% to $0.2. The solution is equipped with a smart management system to manage lithium and storage systems through cloud. O&M becomes much more efficient as it is remote. Frequency of on-site visits is reduced from more than 12 times a year to 3 to 4 times a year. Reliability of our solution is up significantly to 99.99% compared to 95% of the diesel generator solution. iPowerCube S is the off-grid solution for medium-scale scenarios. It has a pre-integrated all-in-one architecture, while its traditional counterparts normally take a split-type architecture with large footprint, long construction cycle, and high capex. Adoption of isolation transformers also increases cost, so does the AC-DC separation approach for greater reliability purpose. For this traditional architecture to be on-grid, power distribution systems have to be modified to support bidirectional power distribution. That takes long construction period and high cost. Our all-in-one solution, however, is pre-integrated. It helps significantly bring down cost, reduce footprint by more than 70%, and shorten construction period by more than 50%. Capex is saved by 8 to 10%. Our MIMO architecture supports multiple input sources and output modes. On input side, it supports PV systems, mains, and diesel generators, and their integrated scheduling. On output side, it supports both AC and DC. All you need is one and only one system. Reliability is high. Since all the critical parts have N+1 backup, there is no single point of failure. Our reliability is over 99.99%. iPowerCube S, with its many strengths, can support myriad scenarios, including hospitals, schools, farms, and oil wells. Deployment is fast. Vessel Traffic Service Station in Hebao Island of Zhuhai, China, is one example. With this solution, the station's LCOE dropped by 60%, and diesel generators are no longer needed. Remote management and control is supported in O&M. Technicians no longer have to take a boat to the island, except for the regular inspection once per year. The navigation station ensures safe and navigation of vessels. It values reliability. Our reliability is up to 99.99%. All critical components of our system have N+1 backup. For low power scenarios with no or very unstable grids, we offer our iPowerCube M solution. The power supply system and battery packs of iPowerCube M can be quickly, flexibly deployed. The integrated design is stylish. It is a suitable solution for scenarios with frequent outages, such as apartments in Nigeria and India. iPowerCube M supports fast charging. 1 to 2 hours charge can sustain stable power supply for 24 hours. For country house scenarios, we support overlay of PV panels. iPowerCube M is a compact solution combining inverter and storage functions. With faster charging, it can steadily supply high-quality power for 24 hours. In scenarios with frequently disrupted grid electricity, we support seamless 0-second switchover between iPowerCube M and grid power supply, ensuring continual power supply in families. Seamless switchover also saves the need of diesel generator backup. The overall solution supports multiple smart features, such as leveraging peak valley pricing and utilizing off-peak electricity to help users save money. The solution uses natural heat dissipation and makes no noises. Users can enjoy quiet and stable power supply. The noise is below 29 dB. For villa-like scenarios, it can supplement other main green power sources or serve as a major power supply source by itself. Integrated scheduling of grid power, solar power, and diesel generators is possible. The solution is widely adopted worldwide in apartments, households, business stores, restaurants, business outlets, transportation stations, and so on. It is successfully applied in Inner Mongolia of China to supply power for local herdsmen. We combine solar power with small wind turbines to supply power for herdsmen, scattering over the steppe, reducing their electricity cost by more than 50% compared to traditional diesel generator-enabled solution. It is much quieter with a noise of 29 dB compared to 75 dB of diesel generators. The solar power is generated for self-consumption. Fan-free design ensures high reliability of 99.99%. It is very suitable for apartments in countries like Nigeria, South Africa, and India, where outages are frequent. 1 to 2 hours fast charging is enough to steadily support 24 hours power supply. Simple and faster deployment saves the trouble of changing distribution systems for non-grid purpose, for on-grid purpose as traditional solar systems do, and the latter has long deployment cycles and high cost. iPowerCube epitomizes fast, simplified deployment and high reliability in power supply. That's all about the small, medium, and large-scale scenarios supported by iPowerCube. Actually, we have leveraged our fundamental technologies to align energy flow and information flow. We have leading electric and electronics technologies at material and component level for power topology and heat management. We also have digital technologies such as sensing, connectivity, AI, and cloud. With these technologies, we are managing watt with bit, realizing smart energy management. This effectively supports our all-scenario diesel generator removal solution to provide stable, high-quality electricity to people's life and work. Compared to traditional solutions, our solution is faster in deployment, lower in cost, more reliable and stable. Moreover, we're open and seek win-win cooperation. Huawei is ready to work with all industry partners to contribute more to green integrated power supply, to bridge energy divide and promote green development of the world with digital energy technologies. I will end by calling on everyone to act for decarbonization and green energy. Let's start from now on. Thank you.
Today is the first day of SNEC, and Huawei's exhibition hall is still packed with people and a warm atmosphere. However, we have tried our best to record this pageantry of each exhibition booth for you. Before we start, please everyone take 2 minutes to complete the questionnaire. We will draw the third prize, the second prize, and the first prize among these who have completed the questionnaire before the summit ends. Now, we will take you through all the solutions presented by Huawei and SNEC.
Hi, my name is Helen from Huawei marketing team. I'm now broadcasting from SNEC 2021 in Shanghai, the largest solar and renewable energy exhibition. There are many innovations and cool solar techs, and we expect more than 2,000 companies and 260,000 visitors to the exhibition this year. As we know, the only way to achieve carbon neutrality is through energy transformation. That means low carbon energy, electrification, and intelligence, which are our key paths forward. We can use this to manage watts and data flows to manage energy flows. The end goal is building more flexible, open, and intelligent energy networks. Together with renewable energy, digitalization will be a powerful driving force for a greener, more sustainable society. This year at SNEC, we are presenting our full suite of products and latest innovations from our digital power business, ranging from utility-scale energy storage to zero-carbon ICT solutions. The digital power market is poised to reach more than $80 billion by 2025. Let's check out the best of Huawei from SNEC 2021. In terms of energy supply, solar PV and wind power will gradually become our primary source of energy. Solar and wind power will increase from 20% of total supply to over 86% by 2050. This will be a key factor in zero-carbon power generation. This year, we have launched FusionSolar all-scenario PV and storage solution, which unlocks the advantage of smart string design, such as intelligence, modularity, multi-MPPT, high protection, and so on, and comprehensively reinvents the power electronics architecture and creates the world's first Gemini plus-minus 1,500 volt design. This architecture design can help to support larger subarrays, higher voltages, thus could reduce LCOE by 7% and even enhance the grid, redefine the PV plant standards, and it could adapt to large-scale wind, solar, storage projects as well. As you know, there are two main topics that are widely discussed in the industry currently: carbon neutrality and energy storage. In the traditional energy storage solution, multiple modules are connected in series into a rack, and multiple racks are connected in parallel. Thousands or even 10,000 modules are coupled with each other. If one module fails, it will affect the others. For our solutions, we could help our customers to avoid this issue and reduce the LCOS by up to 20%. How do we do it? Our solution is through the battery pack level and rack level optimization. The solution can achieve more refined management with the accuracy of no more than a dozen batteries, which is far better than the traditional solution. Besides, the refined management can achieve precise management of each pack with optimized depth of charge, which improves the available power of the system. On the other hand, this innovative design can support the mixed use of new and old batteries, and the phase charging can help customers to save initial investments. In terms of energy consumption, electric energy will surpass oil by 2050. It will go from 20% of total consumption in 2017 to 49% by 2050, and it will eventually replace fossil fuels entirely. For commercial and industrial customers, we are bringing you into our zero carbon compass zone and walk you through our solutions to help business and organizations to reduce their carbon emissions with many cool technologies. Many organizations in the world are facing the challenge of high electricity bill. We are presenting our full PV and storage solution for the first time for our CNI customers, where we are showcasing real customer case of pure PV, pure energy storage, and PV storage and charging, and finally off-grid scenarios. And for ICT sectors, earlier this year, we have released our latest offerings in the energy solution, the Zero Carbon Network. The Zero Carbon Network is mainly designed to help telecom operators worldwide to reduce their energy costs, increase green power generations, and to realize carbon neutrality in their business operations. As digitalization continues to change the way we live, energy costs increase sharply and the demand for energy also increases. Huawei's Zero Carbon Network solutions is integrated by Huawei's intelligent power cloud to realize the carbon neutral targets. First, the simplified site can simplify each telecom base station to minimize size and energy costs. Second, the simplified equipment room utilizes prefabricated and modular components to reduce costs of both the new room and the extension of the existing rooms. Thirdly, the simplified data center will use indirect evaporated cooling and eye cooling to reduce cooling costs up to 70% and use cloud operation and maintenance to increase O&M efficiency by up to 35%. And finally, green power for all utilizes renewable energy, including wind and solar power, on and off grid to reduce carbon emissions. At the individual level, it's everyone's dream to live in a green and smart home, where our energy is coming from renewable sources like solar PV, and also we could manage the energy with smart devices. More than 500,000 homes from 100 countries have adopted Huawei Smart PV residential solution. This year, we have also upgraded our offerings and we call it 2.0 and make our solutions more efficient and smart. With the optimizer and our flagship product Luna 2000 Smart String Energy Storage, our residential portfolio could support more scenarios, whether it's grid connected or off grid, and it could help our customers generate more than 30% more energy and achieve zero electricity bill. We are also presenting a new feature here, PV and storage and consumption AI synergy function, which helps to make your PV system smarter. Through our FusionSolar app and big data analysis, we could analyze different scenarios and help to optimize how you utilize the energy, either directly from the PV system or from the batteries. Besides living in a green home, we could also travel with green vehicles. You might have heard about the recent news that Huawei has helped many car manufacturers to build smart EVs, for example, Arcfox Alpha S and Series SF5. One of the key features that people are looking for when choosing EV is the charging experience. Huawei provides Drive One on the vehicle to help EVs to provide an optimal charging experience for the user. Within 10 minutes of charging, Arcfox Alpha can extend the mileage to almost 200 kilometers. We also provide solutions for charging stations, and the solutions have been widely adopted in China and overseas. The energy sector requires many parties to work alongside each other. With profound experience in information technologies, including big data, AI, and cloud, we can see the potential and the need of creating an energy cloud, which will help to manage energy production, transmission to consumption. Our goal is to speed up the digital transformation of the energy sector and promote a zero carbon and smart society. To date, Huawei's digital power solutions have been deployed in 170 countries and regions. They serve more than 1/3 of the world's populations. These solutions have generated 325 billion kilowatt hours of electricity from renewable sources. That's like planting 220 million trees. Huawei's greatest value is through technology innovations to help more industries reduce carbon emissions, accelerate energy transformation to build a low-carbon society, and achieve carbon neutrality. If you would like to know more, please stay tuned, and our expert will be sharing more details, and we look forward to seeing you in our next event. Stay safe and take care. Thank you.
Huawei has just released the FusionSolar 8.0 Gemini. What are the advantages of this new solution architecture? How does it ratify the PV plant standard? You may find the answers in the following introduction. Next, I'd like to invite Guomei Chen, Marketing Manager of Huawei Smart PV.
Hello everyone, I'm Mei Chen from Huawei FusionSolar. Today I will guide you through this most compelling new products at SNEC, FusionSolar Smart PV and Storage Solution. Let's start with FusionSolar 8.0, the first Gemini plus minus 1,500 Smart PV solution. FusionSolar 8.0 consists of 4 core devices: Wireless 2000 Smart String Controller, Sun 2000 Smart PV Hybrid Controller, Luna 2000 Smart String ESS, and Jector Smart Transformation Station. Traditional string inverter provides voltage boosting and invertering functions. Gemini is the first bipolar string inverter. Smart String PV controller and Smart Hybrid controllers achieve 3,000 watts with plus minus 1,005 watts design in the DC side. The Smart PV controller functions as MPPT and voltage booster in the DC side. There are 8 MPPTs in one device. Each MPPT connects no more than 4 PV strings. Smart PV controller supports high current modules, while the input voltage on the DC side is still 1,005 voltage. The smart hybrid controller functions as a bidirection inverter with rated power of 315 kilowatts at 40 degrees. FusionSolar 8.0 supports DC coupling of PV and ESS and uses advantaged algorithms to achieve 4 major goals: optimal investment, higher yields, safe and reliable, and smart O&M. While achieving higher voltage, FusionSolar 8.0 meets all existing standards and regulations related to electrical and safety regulation for the PV power plants, supporting MEA sub-arrays with higher current modules and higher DC-AC ratios to provide higher power generation, lower capex and system cost. I will go into more details. First, the ±1500 system architecture uses higher voltage and therefore reduce current. Thinner cables can be used, saving cable cost by 0.83 cent/watt. Second, with the sub-array size expansion, the number of sub-arrays will be reduced, meaning fewer transformer and medium voltage devices will be deployed for lower costs. At the same time, the occupied space and construction cost of main circuit and transformer laid inside the sub-array, the number of ports and terminals of medium voltage booster station, and the number of monitoring and fire extinguishing facilities in the sub-arrays are reduced accordingly. With all those savings, the overall equipment and construction costs can be reduced by 0.36 cent/watt. Third, the number of transformers in the super sub-arrays is reduced, and the MCCBs are replaced by fuse switches to implement low voltage zero-arc flashing as well as on-load cutoff. Therefore, the O&M cost of medium voltage side will be further reduced by 0.1 cent/watt. In addition, Huawei FusionSolar 8.0 solution can effectively support the DC coupling solar storage solution. Compared with the traditional AC coupling solution, Huawei FusionSolar 8.0 solution saves the equipment and construction costs of PCS, energy storage transformer, and cables, which consequently reduce the system cost by 4.7 cents/watt. One significant advantage of Huawei FusionSolar 8.0 solution is that it can increase energy yields by 2%. In the ±1500 bipolar string architecture, the current between smart PV controller and between smart hybrid controller can compensate for the AC air loss and increase the energy yields by 1%. FusionSolar used the ±1500 watt bipolar PV string architecture. The cable loss is reduced by 0.23% compared with that of traditional PV string controllers. The intelligent PV string controllers supports output power overshooting and compensates for high voltage DC cable losses. Its energy yield is also higher than that of traditional PV string controllers. Huawei Smart Tracker Control Algorithm analysis mass data from tracker performance experience and use AI to analyze the optimal angle for trackers to avoid shading and maximize the output power of each inverter. Also, SDS can smartly identify cloudy days with power fluctuations and adjust angles accordingly to collect more solar energy. Smart Tracker Control algorithm has been operated at several solar plants in China and India. In one Guangxi plant, after the 4 months operation, the energy yields with Smart Tracker Control algorithm increased by 1.69%. Huawei FusionSolar 8.0 solution provides reliable DC side and AC side safety protection. On the DC side, Smart String Disconnector is deployed to protect power plants. In the traditional central solution, short circuit cannot be protected by combiner plugs, as the fuses cannot be disconnected instantly. The short circuit current ranges from 331.2 amp to 444 amp, which poses great safety risks. In other string solution, as the capacity of PV module and inverter keeps raising, more and more strings are parallel to connected in one inverter, increasing risk of malfunction and even fire. Huawei Smart PV solution accurately detects reverse current connection, internal short circuit, and AC/DC isolation faults. The switch can disconnect the inverter with failure within 15 milliseconds, ensuring PV plant safety. On the low voltage AC side, Huawei uses zero-arc knife fuse switch to ensure zero arcing and high reliability. On the low voltage AC side, Huawei uses zero-arc knife fuse switch to ensure zero arcing and high reliability. Currently, MCCB is often used to effectively cut off faults. However, when MCCB is damaged, it generates spray arcs and requires high-level isolation and protection design. Huawei introduces the strip-type fuse switch disconnector to achieve zero arcing at low voltage. In an on-site test, the Huawei disconnector withstands 50 amperes opening and switches off twice with zero arcing. On the high voltage AC side, Huawei uses smart European transformer and independent SF6 medium voltage Rainman units. At present, the cheap and low capacity American transformer architecture is widely used in China. This transformer uses medium voltage fuse and oil immersed load switch, and the power supply reliability is poor. The protection function is simple, as only the transformer short circuit protection is supported, whereas Huawei's solution uses internal vacuum circuit breaker to extinguish the arc in vacuum mode for high reliability. In terms of operation and maintenance, Huawei Smart PV and ESS management system implements string-level monitoring and integrates Smart IV diagnosis and SDS functions. When monitoring PV plants, we can see the KPI data and accumulated energy yields on the PV plant page. On the PV plant interface, we can see the topology connection of Smart Array controller and the Smart PV controller in each array. The detailed data of each string can also be seen. In Smart IV diagnosis, we can see historical scanning records and main data, including the number of sub-arrays, 40 Smart PV strings, total number of PV strings, diagnosis progress, and diagnosis duration. Then we can select a diagnosis record to view the detailed diagnosis results, including whether each PV string is faulty, fault type, fault IV curve, and fault ratio. In the form of pie charts and curves, the system analyzes the fault type based on the measured IV curve. This is a Level 4 certificate issued by China General Certification Center to Huawei Smart IV Curve Diagnosis. The accuracy, consistency, and recurrency rate of Huawei Smart IV Curve Diagnosis reach over 95%, which is the highest level in the industry. In SDS, we can view information about multiple sub-arrays. For the two sub-arrays with and without SDS, we can compare the energy yields curve and see the energy yields improvement effect of SDS. FusionSolar 8.0 is future-oriented, moving from supporting power grids to enhancing power grids. The PV and storage coordinated control algorithm turns the PV system from an uncontrollable and unstable current source into a stable voltage source, creating the PV generator. In FusionSolar 8.0, a great variety of advanced ICT technologies such as AI and cloud are catalyzed and organizingly integrated with PV. Modules, trackers, cables, array controller, energy storage, grids, and inverters are fully coordinated and fully coupled, including the latest intelligent IV 4.0 diagnostic technology. This embeds intelligent PID protection, SDS algorithm, intelligent grid connected algorithm, etc., which fully releases the potential of each string, create a zero-touch O&M experience, stronger grid support capacity, and so the power plants have three-dimensional awareness, and create an open and efficient intelligent PV and storage system. Now let's move on to the next section, energy storage. This is the first physical display of Huawei Lunar 2000 Smart String ESS. Come on, let's take a look together. Smart String ESS is a standard 20-foot container with rated capacity of 2,064 kWh, a very high power density. As we can see, 6 battery racks are connected in parallel. Each rack has 21 battery packs in series. Each battery pack is 16.384 kWh. Each rack is connected with one DC-DC module, then paralleled into DC bus, and energy is separated into individual PCS. Based on the distributed ESS architecture, the Smart String ESS solution uses innovative technologies such as pack level and rack level optimization, distributed cooling, and modular design to achieve higher discharge capacity, optimal investment, simplified O&M, and higher safety and reliability. And it will ultimately bring about LCOS reduction of over 20%. Sounds quite cool, doesn't it? Let's go further and explore how Huawei makes it. In traditional centralized solution, multiple battery packs are connected in series in one rack. So once capacity attenuation occurs between backpacks, there will be a series of mismatch problems. Besides, during a discharge process, as long as one battery pack is fully discharged, the rest of battery packs with vacant capacity cannot be discharged anymore in order to avoid overcharge, resulting in a huge waste of battery capacity. The pack level optimization in our Smart String ESS solves this problem. The optimizer in parallel with battery packs ensure that every pack can be fully discharged and charged. When battery pack reaches a fully charged or discharged state, the optimizer in the pack starts to bypass the battery pack so that the other battery packs can continue charging and discharging, and every pack can be fully utilized regardless of cell difference. In actual operation, the internal resistance difference of battery racks could be huge due to factors such as factory tolerance and operating environment differences. In each energy storage system, 6 to 12 battery racks are connected in parallel to the DC bus, and the voltage are forced to be aligned. So a battery rack with a lower internal resistance has a larger current and a higher charging speed. It brings about 2 bad effects. Number 1, when a single rack is fully charged, the whole system stops, and the parallel mismatch causes the discharge volume to decrease. Number 2, the uneven flow of each rack is huge, which leads to the heat difference of each rack, aggregates the mismatch, and easily leads to thermal runaway. To solve the above issues, Huawei Intelligent Rack Level Management allows the racks to run differently, eliminating the mismatch between parallel racks, maximizing the potential of each battery rack, and increasing the discharge capacity throughout the lifespan by 7%. In addition, Huawei's solution ensures that the uneven current of each rack is less than 1%, avoiding the security risk of bias current. In Huawei Smart String ESS, each battery rack has an independent air container, reducing the temperature rise difference between battery racks and slowing down the battery capacity attenuation. Besides, Huawei's unique Baltic hybrid air dust design enables air intake from the rear and air supply from the side and the top to ensure the cooling capacity of the cells is similar and reduce the operating temperature difference of the cells. Therefore, the temperature rise inside the container is less than 3 degrees at 0.5 C rate, and the battery lifespan is extended by 50% for higher discharging energy in the lifespan. Safe and reliable operation is achieved by using advanced power electronic technologies as well as ICT technologies such as AI and cloud BMS, To avoid fire risk, Huawei Smart String ESS deploys 4-level safety protection from cell level strengthening, pack level shutdown and isolation, rack level short circuit detection, and 2-tire protection, to system level fire detection and fire extinction. Huawei manages to prevent safety hazard from malfunction protection, early failure protection, and zero runaway suppression for higher system safety and less fire risk. Short circuit inside the batteries is a major cause of battery pack fire. AI-allied smart internal short circuit detection can detect battery fire risks in a timely manner based on subtle changes of cell charging curve, calculate the internal short circuit resistance, capture the slight deviation of charging curve, accurately locate potential risks, and warn fire risks in advance. To conclude, the Smart String ESS solution adopts the innovative string architecture, digital technologies, and module design to implement refined energy management, increasing discharge capacity, achieve optimal LCOS, and eventually achieve a transition from PV parity to PV and storage parity.
Now we are going to draw 5 third prize from the audience who completed the questionnaire. And let me introduce Zhou Xiang, Marketing Manager of Huawei Smart PV, to present Huawei FusionSolar C&I solution, enabling a new array of green and low carbon for various industries.
Hi everyone, my name is Zhou Xiang. It is my great pleasure to introduce our zero carbon city zone, which includes the Huawei FusionSolar Smart PV C&I solution, green ICT, and many more. So let's explore how it enables a new era of green and zero carbon society for various industries. So nowadays, the carbon neutrality has become one of the most urgent missions. At present, more than 120 countries have announced the carbon neutrality plans. So energy industry is an important domain to help achieve the carbon neutrality. Low carbonization, electrification, and digitalization are the essential ways. Huawei Digital Power builds vertical solutions such as green power generation, green ICT, and green travel. In addition, Huawei creates a new smart energy cloud to coordinate the management of sources, the network, the loads, and the storage resources to form a horizontal solution. And this kind of solutions promoting the construction of zero carbon campus in the cities. So next, how does Huawei C&I solution integrate with various industries to help them achieve structural transformation and low carbon energy? Let's check out the details. So Huawei just launched its new C&I solution, which based on the solar plus storage structure and fits for different application scenarios. It's a solar only scenario, storage only scenario, solar plus storage, plus charging, and off-grid. So first, this is a solar-only scenario. The typical feature of the solar-only scenario is that the peak power consumption is mainly in the daytime, and the enterprise's power consumption curve is similar to that of the PV power generation curve, from like 80% to 90% self-consumption. And in this scenario, the business model is like during the day, the investor sells electricity to the enterprise at a PPA discount price to meet the power consumption requirements to the maximum extent. Well, the rest electricity is sold to the grid. And this is a solar-only real case. So this case is a manufacturing rooftop. The roof area is around 1,000 square meters. And the initial configuration is like 150 kilowatt installed capacity. And with four 36 kilowatt inverters and 504 310 watt modules. So there are challenges when they plan to try to power the factory with solar. But firstly, you can see the watt power, the watt power in the building next to the PV plant creates the shadow mismatch, so which reduces the system power generation. And secondly, the traditional inverters cannot cut off the arcs, causing the potential fire risks. So to address these two challenges, the owner replaced the 36 kilowatt inverter with a 40 kilowatt inverter, and the corresponding modules were fully equipped with Huawei Smart PV optimizers. So in this case, when the modules equipment with PV modules, only the panels under the shadows are affected. The other modules can still work as they are the highest power points. And also the Huawei inverters support the intelligent arc protection and automatically shut down within the 0.5 seconds. And also we can see this kind of a chart. According to the comparison of the 1 month PV yield data, the optimizers can effectively eliminate the impact of the shadow effects, and also the power generation is about like from the 5% to 7% higher, and the monthly the energy yields increase at the rate of the 6 to 6.3%, and the annual revenue of this PV plant increased by $3.7 million, which is really amazing. Okay, so now let's move to the storage only scenario. With the increasing popularity of the charging piles, the peak load is very sharp, and the power grid reconstruction and the expansion costs are very high to meet the requirements. So if we use the energy storage battery, we charge it when the electricity is in the valley, and discharge it when the electricity is in the peak section to maximize the use of the peak valley price differences. So here's a model of the energy storage products. So for the industry, the two main challenges of the energy storage system is the battery power loss due to mismatch of the cells and the potential hazards such as the fire and the explosion caused by the external forces, the high temperature, and abnormal battery operation, such as the overcharging and over-discharging. And the Huawei energy storage solution is an intelligent string-based solution. So as we mentioned at the previous topic, the maximum charge and discharge capacity is improved by 15% through the one pack optimization and one rack management. So Huawei's structure is very unique. And take a 2 megawatt hour system as an example. The annual battery power of the traditional solution is 5.45 million kilowatt hour, while that of the Huawei solution is 6.05 million kilowatt hour, increased by the 11% in revenue. Meanwhile, Huawei solution has 4 levels of protection. The first level is cell level protection, which supports the AI-based short circuit detection. The second is the battery level protection, means the pole voltage is 0 voltage. So when you do the installation, maintenance, and transportation, preventing the security risk caused by the accidentally touch. And the third is the rack level protection. So the multi-level intelligent linkage protection automatically disconnect the charge and discharge loop when the battery pack is like overcharging or the over temperature and like the overcurrent. This kind of scenarios, they will do the auto shutdown. And also the 2-level fault isolation of the circuit breakers and fuses, the anti-reverse connection, and insulation resistance detection. The last is the system level protection, which supports the combustible gas detection and the emission devices to proactively exhaust gases to prevent explosion, and the water detection and the linkage protection. So after water flooding, the system is shut off to avoid the electric shock. And here, this is this kind of a model of our 200 kilowatt hour system. So this kind of a system, you can see, this consists of the 12 battery modules, and the total capacity of this is 200 kilowatt hour. And also within this kind of cabinet, there's also a rack management system. So the structure is unique. There's a one pack optimization and one rack management, the structure. to improve our yield, to improve our usable energy of the storage by like 15%. So what if there's a high demand for electricity in the campus? The load is obvious higher than the solar power generation, and the electricity price is high. And let's learn about the solar storage charging scenario. So here is a case of the Huawei Shenzhen campus. The rooftop of this kind of campus is 8,000 square meters, and the initial configuration of the project is a 1 megawatt solar and 900 kilowatt-hour energy storage. And Huawei optimizers are used to avoid the shadow of the HVAC devices on the rooftop. And more than 10% power is generated by installing the optimizers. And the installed capacity is also increased from like 1 megawatt to 1.1 megawatt, 10% higher due to the optimizers. And also from the energy storage, the proportion of the green power supply increased from like 58% to 64%. So at present, Huawei could provide the high quality core components, charging modules for charging stations. Huawei high charger charging module features high efficiency, high reliability, and high valuability. And the Huawei high charger charging module has a wide voltage range. It supports a smooth evolution for charging piles from 500 voltage to 750 voltage, and even a future 1000 voltage. It is highly compatible with different new high voltage vehicles without renovation. And potentially it could save $2,818 per charging pile, protect customers' investment effectively. And also through the thermal field management and Huawei's patent wing shift fan technology, our charging modules support efficient heat dispensing and continuously high power output. Combined with Huawei AI flash charging, it takes less than 15 minutes to achieve from 30% to 80% SOCs. The potential VIP fast charging value-added services may increase the operator's revenue by 6,281 per pile each year. And in terms of the off-grid scenarios, Huawei launched the iPower Cube off-grid, like fuel removal power solution for all scenarios. The intelligent power platform, the PV power generation, and the intelligent lithium battery are used to replace the traditional DG power generation, achieving zero DG operation and zero carbon emissions. The 3 series of iPower Cube covers all scenarios, from small to medium to large cases. As we all know, 5G is booming. Up to now, 160 5G network has been launched around the world. But there are 2 challenges during 5G deployments. The first is high capex and high opex. The second one is the high carbon emissions. So the Huawei's one site, one cabinet solution has a high efficiency and high density design, which enables one cabinet to replace the 3 cabinets, improving the site energy efficiency to 90%. And also, if the one site, one blade solution is used, the site's energy efficiency can be improved to 97%. In addition, the solution requires no floor space, zero rent, and fast deployment within only like 1 hour. Digital acceleration and energy structure transformation holds new requirements for the site power supply. The first is a fast power supply. The second is a converged power supply. The third is a reliable power supply. The fourth is a green power supply. So Huawei Site Power built all scenario solutions in ICT scenarios. It's for communication, IoT, and ICT convergence stations. So Huawei I Super Site solution can provide an outdoor working environment, power supply, security monitoring for ICT equipment. Next one is iPower Site. iPower Site is a one-stop solution for on-site perception scenarios. The stations provide the power supply and network backhaul, and for devices such as bullet cameras, drone cameras, and sensors. The data center industry is rapidly evolving, but faces great challenges to data center construction. Today, it's my great pleasure to talk about the green data center facilities that embrace the carbon neutrality. So this is Huawei Fusion DC.